Alright, so we're going to look at another way to find the GCF, or the greatest common factor. And we're going to that's our second method from our notes, and we call that prime factorization. And we can think of it, it's really the one that you use factor trees for. So this is GCF, and this is by prime factorization. So the way that I'm going to find it by prime factorization is the first step, so I'm going to use the same numbers. We know last time when I did it by factoring, I used 18 and 24. And those numbers are going to be, we know the GCF is going to be 6. Okay, so but this is all about the process. So the first step we do is we're going to create a factor tree for each number. So I'm going to have the number 18, and I'm going to create a factor tree thinking, what can I divide it by? Now you can do any two factors because ultimately you end up with the same numbers. So I might do, for example, 2 and 9. If you have an even number, you can always start with 2. I circle the number if it's prime. 9 can break up into 3 and 3. Circle those two numbers. So now I have gotten all prime numbers here. I can do the same thing, do my factor tree for 24. I could break it up into 2 and 12, or I could do something like I say, okay, I know 4 and 6 would work. I'm going to have to keep breaking them up until I get prime numbers, because those are both composite. So 4 could break into 2 and 2, and 6 could break into 2 and 3. So I've now just finished step 1, and I'm going to move on to step 2. Step 2 we had is list all the prime factors in order of least to greatest, and do not use exponential notation. So normally when I ask for prime factorization, you would want to put the exponents just to make your work look a little bit neater. But right now, we're going to be listing all of them. So I'm going to put 18, and I'm going to list the factors. I have 2 times 3 times 3. I'm going to do the same thing for 24 right underneath it. 24 equals 2 times 2 times 2 times 3. And then the third step, I'm going to circle common factors. Simply for what do they have in common? They both have a 2, so I'm going to circle that. And let me get to the next one. See, there's not a second 2 or a third 2, but they do both have at least one 3. So I could circle at least one 3 between the two of them. Now I'm going to look at how many circles I have. And I have 2 circles right here. That means I'm going to be multiplying 2 numbers to find the greatest common factor. Whatever's in the first circle, that's a 2, multiplied by whatever's in the second circle. 2 times 3 is going to equal 6, or my GCF will equal 6. So we're looking at breaking them down into factors, and then finding what's in common. So we have a 2 times a 3 is in common with both of them. So we do 2 circles, 2 times 3, that gives us 6. Now let's say you had a third number here. Let's say I added in the number 8, and you had to find the GCF of 18, 24, and 8. I would follow the same steps, make my factor tree, 4 and 2, 2 and 2, and then I would list them out. So let's draw a line here. Let's say I was doing all 3 numbers. I would have 18, which is 2 times 3 times 3. I would have 24, which equals 2 times 2 times 2 times 3. And I would have 8, which equals 2 times 2 times 2. Now the number has to be in all 3 lists for it to count. 2 is in all 3 lists. And that's it. I have 3 in these 2, but not in this one, so it's only going to be here. So if I only have one number circled, okay, I'm going to say, well, that's got to be my GCF. My GCF in this case equals 2. That's the only number that I could divide all 3 of those by without having a remainder. It's the biggest factor they all have in common. And I'll stop right there. The next one will be showing method 3.